Hi everyone, and welcome to this edition of Inside the Naval Postgraduate School here on the Pentagon Channel from Monterey, California. I'm your host, Alan Richmond. Well, we begin this episode talking about collaborative research between the Office of Naval Research and the Naval Postgraduate School and support of the warfighter through the use of the free electron laser. We had the opportunity to look at the experiments being done and talk to one of our graduate students as well as several of the professors involved in the project.
What we're doing here initially is developing a new source of electron beams, a new way of making the beams, accelerating them, controlling them, and focusing them. And fundamentally, this is a very hard problem. Electrons don't like each other very much if they're in free space. They try to get away from each other. So what you have to do is, if you want to keep a beam of very high quality, have to make it very quickly, accelerate it very quickly, and then guide and focus it properly to keep it in good shape until you can get it to the free electron laser when you actually want it to do something for you, like make a laser. So what we're studying here is how to do that. Starting off with the electron gun, you see the prototype of the Mark I behind me. That's a new way of making an electron beam and accelerating it very rapidly, keeping it in good quality. We have to merge that beam into a higher energy accelerator. We need to start off at about 1 million volts out of the Mark I and go up to 40 million volts here at NPS before we go into the free electron laser. And the process of doing that is a lot of twists and turns to the beam. It's a lot of focusing, a lot of adjustment. How do you do this while keeping the beam in good shape? Fundamentally, that's what we're studying. The Mark I had its first operational test at the manufacturer's facility about a year ago. I should mention it's the first of its kind in the world. It's the first time the Navy has fully funded a superconducting electron beam source, and the first time that one has actually shown up at a naval facility. So this is a very unique piece of hardware. Getting these things to work is a challenge. There are perhaps 3 in the world that are similar to it in terms of general performance and what it's supposed to do, and this is the first of its kind in particular in the world. It's the first one to turn on in the US. These are hard development projects, and with the advice and consent of Professor Colson, we approached our sponsor, Quentin Salter, and he agreed to let us take a different approach on how we develop these. Usually it's about a 10-year development cycle between the time something like this is conceived and the time it's built. There's a desire to get a final product at the very first go. Everything has to be perfect, everything has to be dead on, it's got to be exactly what you want. When you're doing something truly new, that's hard to do, and it takes a very long time to make sure everything is perfect. We decided with the Mark I, we were going to take a different approach. It's a prototype. We left off a number of things that we know we eventually want, but don't have on the prototype, that will let it work with a higher energy machine. We took some risks. We didn't know that the cathode, the part that emits the electron beam, would work in the configuration that it's in. We didn't know that the RF power feed that lets us provide power to the superconducting cavity and generate these fields that we use to accelerate the beam. That's never been used with a cavity of this type. We didn't know if that would work either. So instead of spending a decade studying it in simulation, we built one. And it turns out that the parts we were worried about work quite well, actually. In fact, better than we expected in some respects. And because of that, we were able to go from concept to initial operation in about 2 years. And we immediately started work on the Mark II design. And that includes features we didn't have in the Mark I that'll let us use it in a bigger machine, fixes some things that we found wrong with the Mark I, and learn and continue. So we've really managed to shorten the development cycle.
The free electron laser is a microwave oven on steroids, in a sense, because it tends to be much bigger, much more expensive, and capable of producing a lot more light. But unlike a microwave oven where the wavelengths are about this long, it's more like microns, or a millionth of a meter, for the size of the wavelength in a free electron laser. The free electron laser is now called an innovative Navy prototype. A large part of the Office of Naval Research budget is carved out to develop these prototypes that are destined to be weapon systems. That decision to make it an innovative Navy prototype was done by 4 stars. One of the most enthusiastic of those was the admiral, 4-star admiral for the Marines. Why he wanted it was that he doesn't want the Navy to have to leave a scene of invasion, for instance, because of missiles flying around. Right now, ships basically have to stay away from missiles and have to stay out at sea so they can't be attacked by missiles. This would give, if successful, and we think it would be successful, the ship the ability to stay near shore, stay in harm's way, and basically shoot down the missiles as they approach the ship. It can work and has worked, the free electron laser, for 24 hours a day for days at a time. So we think we could defend the ship quite a bit of the time with high reliability. So that's the ambitious program. The Navy has really enthusiastically supported it.
We're starting the cool down. We're in phase 2 of the cool down. So on the diagram here, the inner part that's kind of pink is the actual niobium, the superconducting cavity. This is what we call the helium vessel. So the liquid helium is inside there and cools the cavity to superconducting temperature. And then this orange part out here is a copper heat shield that surrounds the helium vessel so that nothing at helium temperature will see anything at room temperature, because the thermal radiation from room temperature in is 45 milliwatts per square centimeter, and that would be too much of a heat leak and cause too much helium to boil. So we cool this to liquid nitrogen temperature as the first step by putting liquid nitrogen in a pipe that's wrapped around here, and then it boils off. And we started that last night, and so the heat shield is cooled to liquid nitrogen now. And we're starting step 2, which is to put liquid nitrogen into the liquid helium space. So liquid nitrogen is about 10 times less expensive than liquid helium, so we try to do as much of the cooling with liquid nitrogen as possible. So we pour it in and wait until this temperature gets down to around 100 Kelvin, and then we can start cooling it the rest of the way with liquid helium. So liquid nitrogen boils at a temperature of 77 degrees Kelvin. That's 321 degrees below 0 Fahrenheit, which is far, far colder than any temperatures that occur naturally on the surface of the Earth, but it's not cold enough for us. We need to go. That's just the first step. So after we finish with the liquid nitrogen, then we'll go to liquid helium and get it down to 4K, which is where we really need to go.
We'll be back to talk with one of our graduate students on this project right after this break here on the Pentagon Channel. Welcome back to Inside NPS here on the Pentagon Channel. Well, if you're wondering more about how the free electron laser actually works, we'll discuss that as well as talk to one of our students and find out about her role in this research.
We're going to start the process of taking the Mark I down to 4 degrees above absolute zero. A couple things have to happen. We have to chill the heat shield down to 77 Kelvin first, and then we have to chill the center down to 77, and then all the rest of the way down to 4 Kelvin. So we'll be using both liquid nitrogen and liquid helium to accomplish this. We always flow liquid nitrogen through the heat shield. That's a thermal intercept. Keeps most of the heat from the outside from getting all the way to the center. Once we do that, we're going to start a detailed study of what happens to the Mark I as we do different things to its environment. As we move the electron beam source back and forth, this is a way of changing the focusing that the beam sees as it emits. It's a core way we have of controlling the electron beam emission process and transport. How does the cavity respond as we move the cathode? These are studies that we didn't have time to do with the manufacturer at NIOWAVE. We now have the time, now that it's here, to do it in detail. What we're doing here really has never been done before. And to have an opportunity as a student to work on something like that, and to have a part of that be part of your personal history is phenomenal. That's something that I've always appreciated as a student, and I like to think I can see it in our students as well. When they really start to get something, really understand that this is brand new, no one's ever done this before, and they're the experts on it. They know more than anybody else in the world about what they're doing. When that light comes in their eyes, that's phenomenal to see.
My thesis is going to be with the free electron laser. I'm designing a cooling system for the cathode stock for the Mark I. So far, so good. We're getting parts in. We designed a vacuum system and a test module to be able to test different cooling systems. We will be able to have a cooling system design that they can apply to the Mark I gun and eventually to the Mark II once it's developed, that will cool down the stock and prevent the superconducting cavity from going conducting from the heat in the stock. To me, the best part is just knowing that this is a system that's going to be able to protect our ships better. It's pretty amazing that you have something that's almost at the speed of light to protect you from missiles that are coming inbound. Because as a fire control officer, I know when we do our calculations on whether we'd be able to hit this missile if it was coming in out on deployment, the odds were not as good as we'd like. So it's really exciting that we'd have something that would give us better protection.
A PhD student graduated last year, Lieutenant Commander Sean Niles, now Lieutenant Commander Dr. Sean Niles, whichever the order that goes in. And he did some of the core simulations on the beam dynamics, how the electron beam is generated, how it evolves as it moves through the beam source. He also participated in the experiments that we did out at NIOWAVE. We've had other students looking at other aspects of electron beam source modeling, electron emission, designing test fixtures for how do you make sure these things work before you put them in an actual gun.
It's an exciting program, and we've brought some new people on board here on campus. Their research will be exciting for us in the future.
Well, special thanks to the Office of Naval Research for their support and the professors and graduate students here at the Naval Postgraduate School on their very important work on the free electron laser. Well, coming up after the break, we'll be talking more about the National Strategic Narrative. Stay with us. Welcome back to Inside NPS here on the Pentagon Channel. Well, recently I had the opportunity to talk with an NPS alumnus, Captain Wayne Porter, who is the author of the National Strategic Narrative. Well, Captain Porter, thank you very much for taking time to appear here on Inside NPS on the Pentagon Channel. We appreciate your taking time out of your busy schedule. Let's start off a little bit about talking about your background.
Yeah, actually, Admiral Mullen once told me I've had the most eclectic career he's ever seen of an officer. So I'm an intel officer, but I'm also surface qualified, steam engineer qualified. I've served in everything as from liaison officer on a British nuclear submarine to a negotiator between the government in Belgrade and the Albanian guerrillas in southern Serbia. I was a political advisor for southern NATO, assigned to Joint Force Command Naples for a while. It was actually there that I transitioned to Admiral Ulrich's staff from Admiral Johnson's staff, and that's where I met Admiral Mullen originally. So when he arrived, I was doing some work as the operational net assessment supervisor. It was a brand new thing for Admiral Ulrich. Admiral Mullen, who happens to have, not that I'm sure he would like me to cite this, but he has an OA background from NPS, which he's quite proud of, I'll tell you. Probably we solve problems maybe in the same way or consider things similarly, so much of what the work I was doing I think resonated with him, particularly at the time I was doing a lot with metrics in operations. And we developed kind of a relationship in the job that I had for both him and Admiral Mullen, so that when Admiral Mullen came to the United States again to be the Chief of Naval Operations, he invited me to come along as his Director of NOOZ.
Well, you've had the distinct opportunity to serve for the CNO and in the office of the Chairman of the Joint Chiefs of Staff. That's quite an honor, and I bet it's been an interesting tour.
Yeah, I actually, 3 of my last 4 tours have been with Admiral Mullen. I was reprieved briefly to go be the N2, the Director of Intel and Deputy Ops at 5th Fleet. So I was there from 2006 to 2008, and then Admiral Mullen asked me to come back to his staff when he was Chairman, and I've been with him now since August of 2008.
Well, I'm sure most of our viewers have had a chance or have heard about your narrative, but for those that perhaps haven't, can you give us an overview of your National Strategic Narrative?
Basically, it's a document that's based on opportunity and hope. I mean, what we're trying to express, or I think the truths that we feel like we've hit upon, is that America's enduring interests revolve around prosperity and security, that those two things are wholly interdependent. You can't have one in the absence of the other. And yet our pursuit of prosperity and security is both constrained and empowered by values that characterize us as Americans. So what we're suggesting in the document is that we need to recognize that hope and opportunity is a strength of America. That is what provides America its shining example to the rest of the world. We have been in the past, certainly, and I think that by reinvigorating the competitiveness that drove us to be great as a nation, and that spirit of competitiveness and innovation is what young Americans are striving for. That's what they're looking for as their mark, their generational mark on where the country's going. we also think that we're probably at an inflection point in history where, similar to where we were, oddly enough, when George Kennan wrote the Mr. X paper, they were facing a threat from the spread of global communism. And we re-wickered our government and our public-private sectors to face that threat. Our sense is that the challenges of the 21st century go far beyond sovereignty. It has to do with the empowerment of individuals and movements and organizations and nations alike. And that in uncertainty, which is the age that we have entered now, certainly, there is great hope. So that our sense is that we need to have a strategy that looks beyond risk and threat and resilience and looks toward opportunity and sustainability, which is really the banner, I think, for the 21st century.
How has it been accepted by the military leadership?
Well, I think it's important to recognize that, you know, as I said, I mean, naivete, hubris aside, what we did finally recognize, and we wrote this in a 3-week period. That was a very short period of time that we put this together. We actually drafted the paper in 3 days. But we had come to a realization that it really wasn't a grand strategy that was needed. It was a story. It was a strategic context. And so it was actually General Mattis who had suggested to me the word narrative at the time. And that's what we seized on. We thought, well, that's really what's missing, is a national strategic narrative that we could use as a touchstone document from which to derive our various strategies. It's been received incredibly well. I mean, overwhelmingly well. I can honestly say that I have received, and I'm sure Puck feels the same, we've received no negative feedback from any member of the military from 01 to up the ranks. It's been very positive. The military's been very supportive of the whole thing, really.
What about outside of DOD, the general public? What kind of response have you had from them?
Well, that's the the irony of this is you go outside the building and they all think, boy, you must have been ostracized in the building. You know, the people in the building think, boy, this really, I don't know how this was received outside the building. It's quite interesting because I think the nation is ready to kind of re-seize our own destiny, to recognize who we are as Americans and our strength. And I think there was something in the document. We tried to write it as a nonpartisan call for unity. And I think it appeals to a lot of people right now, where we are, even civilizationally where we are in today's strategic environment. So outside the Pentagon, it was received incredibly well. It's been cited by some pretty prominent individuals. We're delighted and honored around the world. The fact that Dr. Anne-Marie Slaughter, who was former dean of the Woodrow Wilson School at Princeton and the former George Kennan chair at State Department, was kind enough to write the foreword for us. And folks like Tom Friedman have been very supportive. It's been received very well.
Well, we're very honored to have you here returning to the Naval Postgraduate School, speaking to our students today. What's the message you have for them?
You know, I can tell you, because I never know what I'm going to say until I get up, but I have to admit this. I actually thought about this, and I think the message that I'd like to give the students today is that as I stand before these officers, there's nothing I can probably tell them about leadership. So here we have an incredible group, and diverse group of officers who have most or many of them have been strong leaders already in their career, many of them in combat. There's nothing I can tell them about leadership, but what I am going to encourage them is to be thought leaders and to recognize that the more senior you get, sometimes the more risk you feel is associated with being a thought leader. So while they're young and they have imaginations and they have that fearless attitude, now is the time I'd like to inspire them to use that and to never lose that, to put as much effort into being a thought leader as they do into being a military leader, which they naturally are.
What role do you think the Naval Postgraduate School plays in today's military officer's career through education?
Well, you know, interestingly, don't gauge it by me, but I have 2 Masters of Science degrees from this school, so I'm quite familiar with what the school does. And I think the greatest takeaway that I have from the school personally was, I think, really the ability to apply critical thinking to a bunch of different situations. I think NPS has all of the ingredients. I am a huge supporter of the school, as is Admiral Mullen. It has all the ingredients multidisciplinary, multicultural, international, interagency. It has all of the elements to bring together the right people who can take us into where we need to go, take us in the positive direction the nation needs to go, to shape the right military for the opportunities and challenges we're facing in this century.
Well, it's a pleasure to have you returning to NPS, so welcome home and thank you very much for spending time with us here on the Pentagon Channel.
Yes, sir. Thanks.
The Naval Postgraduate School continues its excellence and relevance in unmanned systems education and research across all domains, ranging from surface to undersea, air to space to ground. NPS recently welcomed members of the Jet Propulsion Laboratory in Pasadena, California, for information and research exchange. Hosted by the Consortium for Robotics and Unmanned Systems Education and Research, or CRUISER, Dr. Larry Matthews gave a standing room-only seminar which introduced a number of recent robotics endeavors at JPL, including a number in support of naval applications. Whether on Mars or in maritime operations, both NPS and JPL can collaborate and leverage each other's expertise and experience to advance the frontiers of robotics. Here's Dr. Larry Matthews of JPL and Professor Tim Chung of Naval Postgraduate School.
Well, at JPL, we're a federal lab, which means we're basically a contractor. We're not civil service. But we're a federal lab chartered under NASA, so that's like our mother agency. So our core mission is unmanned solar system exploration. So we develop autonomous navigation systems for robots for exploring Mars and elsewhere in the solar system. But as a federal lab, we also address other problems of national importance, and so unmanned systems for the Army is very complementary with what we do for NASA. Well, what I do is perception systems for unmanned vehicles, all domains, air, ground, maritime, and space. What I'm here today doing is making initial contacts to get input from NPS in ConOps and technology needs for unmanned systems, and also hoping to build collaborations for future joint research. The number one mission for unmanned systems in all domains is ISR. There's a big demand for that. You know, there's already a lot of stuff in the field with large manned and unmanned aircraft for airborne surveillance, and there's a desire to bring that into smaller systems, lower to the ground. Of course, ground robotics for explosive ordnance disposal has had a big impact in Iraq and Afghanistan. Where we go next with ground robotics, lots of possibilities. It's not clear what the next big win will be. Well, NPS has students from the services, from all the services, not just the Navy. So those people bring experience from having been in the service, an understanding of the needs that will be better than the engineers in the academic community. So we're looking to be better informed about what the needs are. NPS and JPL are geographically close together, so we think it would make sense to try to foster some collaboration on actually doing the research.
JPL is known for being one of the foremost places where we do unmanned space exploration, so robotic space exploration. And we had the opportunity to learn a little bit more about what they offer and what they've done in a long history of space robots. What we've seen today actually is the opportunity to learn more about all the other applications besides NASA that they've worked on, including a lot of things that are relevant to the Department of Defense. One of the great things about JPL is that they have incredible amounts of engineering and technical expertise. A lot of that we can leverage, combine that with the operational experience of our students, as well as the operational relevance of the needs of our Navy. And bringing those two together, I think we can really push forward the boundaries of robotics in a very meaningful way. I think NPS can really help feed the direction that places like JPL and other institutions around can really focus their research in directions that are going to be operationally relevant, things that our students are going to see in the field 5, 10, 15 years from now. We can start helping inform and shape that early on with partnerships with people like JPL. One of the things I'd love for them to learn or experience is the notion that there's so much more that we just don't know about yet, just because we have to open our eyes and ears and learn what other people around in our community and the robotics community is doing. I think that's one of the goals of CRUISER, which is the Consortium for Robotics and Unmanned Systems Education and Research. And I think this is one step towards that goal of broadening everybody's horizons. Cruiser really just brings people together and gives them a chance to chat with one another, share some different ideas, go do everything from developing new concepts of how to use robotics, all the way to testing and field experimentation, which is a great way for our students to learn. So going all the way from ideas and putting your thoughts into real practice, you can really learn quite a bit and do that. And Cruiser is designed, mandated by Secretary of the Navy himself, to help foster that type of an environment and bring some collaborative spirit for the robotics community, not across only the Navy, but also DoD at large.
Well, we'd like to offer special congratulations to one of our NPS Operations Research students, Captain David Cote, who was recently named as the Marine of the Year. Way to go, Semper Fi. Well, I hope you'll join us for our next episode coming up as we take a look at life at sea aboard the USS Stennis with my videographer, Fidel Jacobo, and me. We'll see you next time around. Thanks for joining us for Inside NPS right here on the Pentagon Channel. Goodbye, everybody.